All right, so we're talking about normal approximation to binomial. So remember, with binomial is success or fail, and we've already learned how to calculate average. So n and p gives us average. We did that in a previous lecture. And then the standard deviation is n times p times q. Now, for a quick reminder, n is just the number of trials, p is the probability of success, q is the likelihood of failure. Now, we need to make sure our n times p is greater than 5, as is our n times q. Now, the way to do this is whichever is lower, q or p, we multiply that times n. As long as that one is greater than 5, then both are going to be greater than 5. If it's not, then guess what? You can't use the binomial approximation. Alright, so one of the things with binomial, it's because it's wholes, it's either yes or no, we're going to use either negative 0.5 or positive 0.5 to each x value. So if we have 30 students, we could do 30.5 or 29.5, depending on how we are going to be looking at the question. So if we're defining it as greater than, less than, and we'll go over all of that in a bit. Alright, so part of the binomial is a fixed number of trials. Trials are independent, success and failure, and the constant success is, well, constant, meaning that if it's 0.5 for one trial, it's 0.5 for all. Alright, these are the notation again that we just talked about, n, x, p, and q. Remember, feel free to pause at any point. So we're going to use a normal approximation, and what we're going to look at is, in the previous section about a sampling distribution, we saw that there was 580 of these p's. 0.25 were likely to be one color, yellow, and he got 152 for a rate of 26.2. Now what we need to do is make sure that we can go through and use this for an equation. Alright, so let's check out our requirements. Our P and Q is going to be greater than 0.25, is going to be greater than 5 because we have 0.25 times 580. That's well larger than 5. And we know that they're independent trials, so we are good to go. Alright, so all the requirements are met, so we're going to use the following bits of information. We're going to use mu equals n times p, and then the standard deviation. So let's go through and start calculating it. One of the things, again, we talked about before is continuity for correction. That's either moving up or down by a half. Alright, so let's go through and look at, is Mendel wrong? Is this significantly high? So that means we're going to have to look at this in terms of the high end on where it falls in the z-scores. So let's take a look at this. So we've got 580, which is going to be our n. We've got 152, we've got 145, and we've got 0.25. So let's take a look at this information and convert it all around. So, as you can see, n times p gives us 145. That's our average. Our standard deviation is n times p times q. So it's 580 times 0.25 times 0.75, and we need to take the square root. Do not forget to take the square root. And that gives us 10.483. Alright, so what we're going to do is we got x minus mu, so we ended up with 151.5 because we wanted to see if it was greater than 152. And the reason why we know it's 152 or 151.5 because we're saying, using the discrete, we're saying it was 152 was the total, at least 152. So at least means that you're including that number. So if I want to, you need at least a 90 in order to get an A in the class. That means 90 will get you an A. So therefore 150. So we need to go lower than it. So that's why we're going to go to 151.5. So now that we're at 151.5, we do it minus 145 because that's the average over the standard deviation. Now notice, you'd be like, well, what about the n? We don't have to do the n. It is not part of the binomial in terms of calculating the standard error of the mean. That is only for individual scores. All right, so we do this all through. We ended up with 0.62 right here. And then we throw it into our technology. Again, let's take a look. Now you might think we would do something like this: analysis, probability distribution, binomial. But we're not doing binomial. We're going to do normal because we're calculating a z-score, and a z-score is normal. And so we're looking for at least. So at least is going to be all of the area to the right, because at least is more than, just like with the 90 for the A, so 90, 91. So we can see that it's 0.267629. There we go. That's our area. So let's take a look at and see, is Mendel wrong? Well, we're going to say no because it's greater than 0.05, the probability of getting that. And so it's not significantly high. It's not unusual. All right, so part of the continuity correction, this is a really helpful table that you should look at and make note of in your book. It is on page 287. And just go through and read it. And it's based on these words. This is the information that you're going to use, such as at least, more than, at most, fewer, exactly. So let's take an example. Let's take a look at exactly 152. So from the previous slide, we can tell that it means that it's going to be between 151.5 or 152.5. So we're going to need to calculate two z-scores just like before. I'm going to try to get this area over here. So if we go through and do it, we're going to end up with 0.62 just like we did before, and then we're also going to end up with 0.72. Now we're going to subtract the areas from each other. Remember, do consistent areas. If you do one from the left, you need to do the other from the left. And so this is what we did. We did both from the left, so it's 0.7642 minus 0.7324, which gives us 0.0318. So the result is not relevant, mostly because getting any one specific score is usually going to be unlikely. Getting more or less tends to be a harder thing, and therefore we would use that instead. Now, if you want, for any of this stuff, you can actually use the binomial probability if you don't want to use the z-score. So let's take a look at how to do that. So before, I had just mentioned in this video to use the normal distribution if you're using the z-score. Now, for instance, when you're doing the area between two, you're going to need that. But if you're needing higher or greater than, you can use this as well. So you go to binomial. So let's say for this one we had 580 trials. We had a 0.25, and then we were looking for 152. So there we go. We've got 152. So we've got fewer or greater. And then we could also do 153. Or we'd actually do the 151, and we'd be able to get all the values. I like using the Z method better, but whatever works for you, if you can get the correct answer and makes sense, feel free to use that. All right, so let's take a look at question number 6 in your book on page 289. It says birth of boys with an n equals 8 and p equals 0.512. Now again, this is question 6. We want to see the probability of exactly 5 boys. So what we do in this particular one, we could do the n times p times q, but we're going to do the binomial. 8, 0.512, and we want exactly 5 boys. 5, evaluate, and then we should end up with exactly is going to be 0.22. 879, but we should not use the approximation here. But if we were, we would be having 0.228. But we can do it for number 5. And the reason why we shouldn't do it here is because our 0.512 times 8 is less than 5. But if we were to change that number to 20, all of a sudden we can do it. Alright, let's try number 10. So take a look at number 10, pause this video, and then I will walk you through the rest. So for number 10, it states, find the probability of exactly find the probability that at least 25 cars are black. Is 25 a significantly high number of black cars? Now for this question, we look up a little bit, and it says in exercises 9 through 12, assume that 100 cars are randomly selected. Refer to the accompanying graph to show the top car colors with those based on the PPG industries. Alright, so if we enter in 100, 0.18, 25, we can see that we end up with 0.05 or greater for the or greater part, which is going to make it much more challenging to have it. So it's going to be unlikely because it's less than 0.05. Now when entering in your information, you can make a silly mistake like I did and do 1,000, and then all of a sudden it changes everything. So make sure your numbers are entered in exactly correctly. Alright. Till next time, see you guys next Tuesday. Or, well, not see. Talk to you. Bye.